All right, I want to start off today by doing a little review on triangles and angles because I kind of messed that up the other day in class. And so you'll just have this as a useful resource to help you remember how to do these things. So let's start. Let's draw a parallelogram. Parallelogram is made up of lines that are parallel to each other, but not at right angles necessarily. So we have this parallelogram here. So how do we know what angles are what in this? Let's say here, whatever angle we have here, let's just say that, call it alpha, is going to be the same as the angle here, which is also the same as the angle here, and is the same as the angle here. Okay, cool. What other ones can we find that are the same? We have this angle here, call it beta. It's also the same as this angle here, call it beta. And the angle here, beta. And beta. Cool. Now, we can, so similarly, if we just apply this idea to all of these, we've got theta, 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 theta. And then the last one we have in here that we still need to define, we'll use orange. And we'll call this phi. So you can take a look at this and see which angles are always going to be the same for each of these. Now, another trick to note is that the total angles of a parallelogram have to equal 360 degrees. That's all of the angles. So alpha plus beta plus theta plus phi all have to equal 360 degrees. Now, if I were to go in here and do something like bisect this with a vector or a line in between here, now we have just this triangle. Call it this triangle here. So if I take this triangle out itself, the only angle in there that I have is alpha. The other two are not necessarily theta divided by 2 or beta divided by 2. They're going to be designated using the sine and law of sine and law of cosines. But we know that the total, all the angles of a triangle are equal to 180. So that's something to always remember as well. And the angle between a line, something like this, like alpha and beta that you would see here, these also have to equal 180 degrees. So we can then use this triangle, we can use the law of cosines. We'll just make up new angles here. We'll call this big A and big B, completely different. This is B, this is A, and this is C. So now we would have to use the law of sine or cosines to and sines and cosines to find all of these angles and the sides of the triangle. So that's a quick reminder of the parallelogram law, or how to find all of the angles in a parallelogram.